Hi guys, Terry here again. In this video, I'm going to be looking at the solution to question 3 in the July 2021 CSEC Add Maths paper, right? If you haven't done so as yet, please hit like and please subscribe to my YouTube channel. So let's do third question. Okay, so in the third question here, they are telling us that the coordinates of the center of a circle is 2, 1, right? Center of the circle is 2, 1, and a point on the circumference is 3, 3. And they want us to determine the equation of the circle. Now, visually, I want you to understand what's happening here. So you have the center of the circle here, and you have some point on the outside here, right? Which is 3, 3. So what we can actually do, we can find this length here, right? Now you're not expected to draw this in the exam, but I'm just putting this here so you can understand what I'm doing. So I can work out the length there, right? So this R here is the length because we have two coordinates. So the length, right, of a line segment is given by x2 minus x1 squared plus y2 minus y1 squared. That's how we find the length of a line segment. So R in this case here, so I'm going to call this x1, y1. I'm going to call this x2, y2, right? It doesn't matter how you call them, right? Just be consistent in terms of your labeling. So x2 minus x1 in my case is going to be 2 minus 1 squared plus 1 minus 3 squared, and you're going to find the square root of this. So 2 minus 1 is 1, so this is 1 squared, plus 1 minus 3 is minus 2 squared, square root. So 1 squared is 1, plus minus 2 by minus 2 is 4, so this is the square root of 5. So leave your answer as this, right? So this is my radius of my circle here. Now, you know what the center of the circle is. So the center O is given by 2, 1, right? And R is equal to root 5. Now, if you know the center of the circle and you know the radius, right, the equation of the circle can be written in the format x minus, let's write it for you here. So it can be written as x minus 2 squared plus y minus 1 squared is equal to your radius squared, which in this case here is going to be the square root of 5, right? So let's expand this. So this is going to be x squared minus 4x plus 4 plus y squared minus 2y plus 1. When I square the square root of 5, I'm going to get 5. So this here is going to be x squared minus, x squared plus y squared minus 4x minus 2y plus 4 plus 1 minus 5 is equal to 0, right? So let's simplify this. So this is going to be x squared plus y squared minus 4x minus 2y. 4 and 1 is 5, 5 minus 5 is 0, so this is equal to 0. So this here is the equation of my circle, right? So that's part A. In part B, well, so that's A part 1, right? So A part 2, they said the circle intersects the x-axis and the y-axis at 3 points, right? Now visually, right, I'm going to show you that this is 1 point here, this is 1 point here, and this is 1 point here, right? So visually, this is what's happening. You need to find this point, and this point, right? But we're not drawing the graph to find the point. We're going to actually use the fact that on my x-axis y is equal to 0, and using the fact that on the y-axis x is equal to 0. So that's what I'm going to do, right? So let's start. So for your x-axis, right, y is equal to 0 for here, right? So the equation of the circle was x squared plus y squared minus, what it was, minus 4x minus 2y is equal to 0. So we're going to say when y is equal to 0, what's going to happen is x squared plus 0 squared minus 4x minus 2 by 0 is equal to 0, right? So this is going to be x squared minus 4x is equal to 0, right? So when I factorize this, I'm going to get x minus 4 is equal to 0. So therefore, I'm going to get x is equal to 0, or I'm going to get x minus 4 is equal to 0, and therefore x is equal to 4. So 2 points here, right? The first point on my x-axis will be 0, 0, and the second point is going to be 4, 0, right? Let's see if we get that. All right, so 0, 0 and 4, 0, so those are my points on my x-axis, right? So this is one part here, right? And on your y-axis now, what's going to happen is that x is equal to 0. So we're going to start off with the equation of the curve again. So x squared plus y squared minus 4x minus 2y is equal to 0. So on your x-axis, sorry, on your y-axis, x is equal to 0. So when x is equal to 0, we're going to say 0 squared plus y squared minus 4 by 0 minus 2y is equal to 0. This is going to give me y squared minus 2y is equal to 0. If we factorize this, we're going to get y into y minus 2 is equal to 0. So we can say either y is equal to 0, or we can say y minus 2 is equal to 0. So y is equal to 2. So therefore, this point here on your y-axis is going to be 0, 0. And on the x-axis, it's going to be, sorry, on the y-axis, it's going to be 0, 2, right? Which is what we have here. This is 0, 2 here, right? So we found our 3 points that they want, right? And let me use a different color to show you those 3 points. So let's go back. Where's the question again? Right. So they said the circle intersects the x and y axis at 3 points. So 0, 0 is a point, 4, 0 is a point, and 0, 2 is a point. Because 0, 0 is, we found it twice. Right? So that's the answer for this part here. In this part here now, we want to determine what is the equation of the tangent to the circle at the point 3, 3. So let's go back here to my curve. So this here is my point 3, 3, and this here is my tangent. Right? That's my tangent. Right? So what we can do, we can use the point O and E to find the gradient of the line OE. So the gradient, right, of a line segment is given by y2 minus y1 over x2 minus x1, right? Now where am I getting those things from? So it doesn't matter, like I said, how you label this. So you can call this x2 y2, and you can call this x1 y1, right? In which case it'll be 3 minus 1 over 3 minus 2. So this is going to be 2 over 1, which is going to be 2. So your gradient of OE, right, is equal to 2. But the thing is, your tangent is actually perpendicular to that line, that gradient you just found it, right? So the gradient, so we're going to say, therefore, the gradient of tangent, right, because it's perpendicular to the gradient we just found, all we need to do is to invert it and put a minus sign. So the gradient of the tangent has to be minus a half. What I'm using here is the fact that the gradient of a line multiplied by the gradient of a line which is perpendicular, it has to be minus 1, right? So this is one of your coordinate geometry rules that we need to be aware of. So you know what the gradient of the tangent is. So the gradient of the tangent right is minus half, right? And we know that it's passing through this point here. So the point that it's passing through is actually 3, 3. So therefore the equation of the line is going to be y is equal to, remember the equation of all straight lines follow this format, y equal mx plus c. So m in this case is minus a half x plus c. And what I'm going to do, I'm going to use this point to figure out what c is. So when x is equal to 3, y is equal to that same thing. So therefore 3 is equal to minus a half multiplied by 3 plus c. So therefore c is equal to 3 plus 3 over 2. So therefore c, right, so that's 1.5, so that's going to be 4.5, which is what, 9 over 2, right? So that's what I'm getting for my c. I'm getting 9 over 2, right? So therefore the equation of the tangent right is y is equal to minus a half x plus 9 over 2. Now you can leave your answer like that if you want, right? Or you can write it as 2y is equal to minus x plus 9, or we can say 2y plus x is equal to 9, right? Either one of these here will work for your answer, right? That's not a problem really, right? So that's the answer for the third part. The next part here now we have position vectors. So we have two position vectors, right? OP and OQ, and they want a unit vector in the direction of PQ. So before we can do anything, we need to figure out what is PQ, right? What is the vector PQ? Now 2 minus 3 is maybe here, and minus 4 minus 1, sorry, minus 4 1 is going to be up here, right? Now let me just draw a simple diagram here. Don't worry about the exact values, right? So I have my origin here, right? And now this is just for me to understand what is required. Diagram will not be accurate, and that's fine. So the vector OP, so this is P here, this is Q, OP is 2 3, and OQ is 4 minus 1. And I want to figure out, first of all, what is the vector PQ. So PQ, right, is actually equal to PO plus OQ, right? So the vector PO, you're going in the opposite direction to this vector here. So therefore it's going to be minus 2, positive 3, plus OQ, which is going to be minus 4, 1. So this here is minus 2 minus 4 is going to give me minus 6, and 3 and 1 is going to give me 4. So this here is minus 6, 4, right? So that's my vector PQ. The next thing we need to do now, we need to figure out what is my length of this vector. So PQ, right, that's the magnitude of the vector, is going to be equal to minus 6 squared plus 4 squared, and you're going to find the square root. Minus 6 squared is 36, right, plus 16, right, and that there is going to give me what, 3 and 1 4, that's going to give me 52, right? So this here is going to be 52, the square root of 52, right? Now we can decide to write this in a simpler format, right? 52 can be written as, let me see, 52 by 4. I can write this as 4 multiplied by 13, right? Which is the square root of 4 by the square root of 13, which is going to be 2 root 13, right? So that's my magnitude there. Now we want to find a unit vector, right, in that direction, right? So a unit vector in the direction PQ, right? All we need to do is to take whatever the vector PQ is, right, and we're going to divide it by 2 root 13. So all we need to do is to say 1 over 2 root 13 multiplied by whatever the vector PQ is, which is going to be minus 6, 4, right? And that's it. That's all we need to put there. We can stop there, right? What they want, let me see something. Do they want us to simplify it? Given your answer in a simplest third form, right? So I'm gonna just simplify this a little bit, right? So let's see, 1 over 2 root 13 multiplied by minus 6, 4, right, is going to be equal to minus 6 over 2 root 13. That's the number on top. And the number at the bottom is going to be 4 over 2 root 13. Right? And I can probably write this as minus 3 over root 13. And the number below will be 2 over root 13. Right? So if they wanted to simplify, this is the best I can simplify this here. Right? Minus 3 over root 13. 2 over root 13. Right? That's the best we can write that there. And the last part of the question now, they said cosine m is 24 over 25 and the angle m is acute. When we say acute, that means we are less than 90 degrees, right? Less than 90 degrees. Now, you know that cosine m is 24 over 25. So let's draw our quadrants here, right? And let's see if we can write what this angle is here. So let's draw our triangle in our first quadrant, right? Our right angle triangle. Now this here is my angle m, right? And we're dealing with cosine, right? So if you all remember, cosine is equal to adjacent over your hypotenuse, right? But that here is equal to 24 over 25. So your adjacent is going to be here. So this here is 24 and your hypotenuse is going to be 25. So what we want to do, we should find this length one time, right? Which is your opposite. So we can use Pythagoras' theorem there, right? Let me call that opposite, right? So if we're using Pythagoras' theorem, we're going to see that the opposite squared is going to be 25 squared minus 24 squared, right? So your opposite squared is going to be so this is 625 minus 24 squared. You're going to get 576. So opposite squared is equal to 625 minus 576. You're going to get 49. So the opposite length there is going to be square root of 49. So your opposite is going to be equal to 7. Right? That's going to be important for us, right? So we have all the lengths of the triangle there. Now the question wants me to work out tan 2m, right? So we're going to have to use one of our rules regarding double angles, right? So tan 2m is going to be 2 tan m. So this is what I'm going to use. Tan 2m is going to be 2 tan m, right? Over 1 minus tan squared m, right? So it's 2 tan m over 1 minus tan squared m, right? Now all we're going to do, we're going to make use of tan. So tan m, according to my triangle, remember tan is opposite over adjacent. So in this case, tan m is opposite, which is 7. We just worked that out, over 24. So you know what tan m is. So it's going to be 2 multiplied by 7 over 24 all over 1 minus 7 over 24 squared. So the numerator, right, is going to be 7 over 12 divided by, and we need to work out the numerator there, right? So that's going to be 1 minus 7 over 24 right? And what I'm getting here, right, I'm using the fraction part in the calculator, which is going to help me. So this is 527 over 576. So when I divide this now, I'm going to get I'm getting 336 over 527, right? So I'm getting 336 over 527, right? So we're working in fractions here, guys, because I said determine the value of tan 2m. So there's the answer here, right? That's your answer. Right, so that takes care of my third question in this paper. So like I said, please hit like and subscribe. And those of you who are interested in add maths, chemistry and physics, you can send me a WhatsApp at this number. Alright guys?